All right, so here we got some review questions on exponential functions, and I'm not going to do all of them because there's some that are a little bit repetitive. But the main idea with an exponential function is that the amount that you have at any time, which we could call f of t, so that means the amount at any time, is going to be your starting value and then your multiplier raised to the t, like that. So I know you've probably seen different letters used in the past, but it doesn't really matter what letters I use as long as I tell you what they mean. So I'm just using S for the starting amount, M for the multiplier, and then T for the amount of time. Sometimes things can get tricky where it doesn't multiply it, like, say, every 1 unit of time. Like, for example, we might tell you something takes 2 years to double, or 7 years to double, or it might double every 1.5 weeks or something like that. If there is a certain gap in your time, you just divide your gap like that. So that's what I'm using. So S is just your start, M is your multiplier, T is your variable, time, and then G is your time gap. Okay, so I'm just going to skip around and do a couple of these. So here's my equation. I have 4,000. Earning 4% interest becomes 1.04. Why does that work? If you earn 4%, that means you're adding 4% on to what you already have. So that means you have 100% of the original plus 4% growth. It makes 104%. And percent means to divide by 100. Percent divide by 100. So that's why I got my M of 1.04. And then my T value goes right up here. I don't have any G, I don't have any gap because it does that annually. It does it every year. How much will I have after 6 years means I just replace the letter T with 6, type that into the calculator, whatever pops up is the answer. Doesn't really matter so much what the answer is, the setup is the important part. The next one here, we've got the house, 450,000, increases by 12%. So that's 112%. How long? 20 years later. Where did I get 20 from? That's the difference between 2010 and 2030. I'm going to skip down a little bit. Here we have something that's losing value. So before I did 100 plus the percent, here I'll do 100 minus the percent, which means 77%, which means 0.77 is my multiplier. If something's decreasing, then you're going to multiply by a number that's smaller than 1. So this is what I would type in. Whatever pops out is your answer. All right, moving down, we're going to do some stuff with logarithms. When you have an equation where you have a variable in the exponent, you want to use a logarithm to solve for it. So I take log with a base 10 on both sides because that's going to cancel out the base 10. So x is going to equal log base 10 of 225. Remember that the base stays on the bottom. So if you had a base of 10 raised to the x, then you're still going to have a base of 10 in your logarithm. The button on your calculator that says the word log is programmed to mean log with a base of 10. Okay. Same idea on this next one. I'm just going to write it as log base 8 of 123 equals x. What did I do there? I did the log base 8 of the left side, and I did the log base 8 of the right side. Logarithms cancel bases. If you had to type that into your calculator, you would just press the math alpha, which is the green button, and then math, and you'll be able to type in log base 8. If that doesn't work during the test, just ask, and we'll make it work. Now we're asked to use e, so we're using a base of e. When we use a base of e, our equation looks a little bit different. Our equation looks like this. Start times e to the rate times t. So here we have a function. The town starts at 33,000. E Our rate is 4.5%, so percent means divide by 100. That's why I got 0.045 raised to the t value. Okay, let's skip on down a little bit more. Solve using any value, or solve using any method here. You're just going to divide by 400. So e to the 0.05t equals 130 over 4, 13,000 over 400. Then I can do the log base e of both sides. There's a button on your calculator, the LN button. It's right next to it. That does a log base e. So 0.05t equals the natural log of 130 over 4. You can get a decimal if you want to. And then you just divide by 0.05, and whatever that is your t value. Okay, let's see. One last one that I'll do in this video. You can ask questions too if there's another problem in particular you want it. I'm happy to do it. If we have a graph of y equals log base 10 of x, then that means we also have a graph of 10 to the y value equals x. And that is going to be crucial for explaining this here. The reason that 1,000, 3 is on the graph is because 10 to the y value is equal to the x value. What is the x-intercept of the graph? In other words, what is the x value when y equals 0? Well, 10 to the 0 equals 1, and that implies that log base 10 of 1 equals 0. That means that this is not hitting at the origin, it's hitting at 1, 0. Just can't tell the difference because of the scale. Where will the graph meet the line y equals 4? Well, we know 10 to the y equals x. So we need 4 zeros. So that means that it's going to be the point 10,000, 4. So that was a really quick overview of exponents and logarithms. Let me know if you have any specific questions. I'm happy to help out.